Hello and welcome everyone to this month's NetAlly Tech Chat. My name is Julio Petrovich, Product Manager at NetAlly. And today we have another super special guest with us. We got Mr. Lee Badman. Hey Lee, how you been?
Good, Julio. How are you?
Oh, pretty good, pretty good. Nice to have you here with us today. And before we get started, and before I forget, guys, a few very basics. So we like to keep these tech chat sessions as interactive as possible. So if you have any questions, feel free to type those under the questions section, and then I'll read those to Lee live. So keep it interactive. If you have questions, feel free to ask them, and we'll answer those as we go through this session. Then anyway, I guess it's time to get rolling here, Lee. So it sounds like you have a very interesting topic for us today on wired issues that cause Wi-Fi problems. So what will you be talking about today and sharing with us?
Well, first of all, thanks for having me, Julio, and hello to everybody who's in attendance. Yeah, so, wireless is nothing without wired underneath generally. And, in the many years I've been doing wireless, a lot of times, fairly frequently, almost all the time, pick your spot on the gauge. Too often the wireless problems are actually caused by something underneath, and there's a whole list of them. But today we're going to be talking about an interesting subset. I mean, you've got everything from DNS to what have you, but we're gonna take a look at VLANs, ACLs, quality of service, and tunneling in particular out of that entire big range of potential wired problems. We're going to kind of talk about a subset. So the only reason I want to, squeeze that in the beginning is this is not definitive or absolute, right? We all know that there's a lot more than what we're going to be talking about on the wired side that can cause problems for wireless users. So just set the tone and the context.
Yes, indeed. And I've heard, and I don't know if this is a real statistic or not, that sometimes like 80% of those supposed Wi-Fi problems are really on the wired side. And like you said, there's a lot of different reasons on the background. We're just talking about a few here today. But is that like a real stat, or on your experience, is it more like a 50-50?
Yeah, I guess I would have to give that some thought. In my experience, the absolute vast majority of problems on wireless, on a network that's been set up by people who know what they're doing, the absolute vast majority is the client, something about the client, bad password, bad driver, bad misunderstanding of what they're supposed to be doing procedurally. Something is absolutely on the client side. But if you take that out of the discussion and come back to your statistic, yeah, probably so. And if you take out like vendor code issues, the controllers and the access points, you also have to pull that out to say, okay, what's left? And then absolutely, especially where you have complicated enterprise environments where wireless and wired are both in play at a grand scale, then yeah, especially where there's lots of people touching lots of things, and maybe change control isn't what it's supposed to be. But so I would say yes, you're right. Sure, I'll buy that with some qualifiers.
Okie doke. So where do you want to start then?
Shall we dig in?
Sure, let's do.
Okay. And I will try to move it along. I don't like, are we viewing my screen?
Yep, looking good.
Okay, there we go. So I don't want to be a slave to the slides, but at the same time, they'll just kind of be a roadmap to guide us through the topic at hand, just mentioned. And then I kind of started to get into this 802.11, you have to have the wiring underneath it. Generally, the 802 part is common. and that makes for some interesting discussions as we'll get into. Generally, even where you have a fully wireless environment, which more and more environments are going all wireless or almost all wireless, you've still got wires running to the access points to go back to switches. You still have a networking component, and you've still got a lot of variety, whether it's work from home or small business or the big enterprises, whatever. You have to have some kind of handle on the environment that you're having problems in if you want to have success troubleshooting. Even though it's all, quote unquote, standards based, I think we probably all know, or we should know, that still leaves a lot of room for variability. And then my bottom bullet there, there's a reason I starred that. The single client issues generally, we're going to be talking about the kind of stuff that impacts multiple users. And the only reason I put an asterisk on that is just ran into an interesting one with a particular leading vendor's equipment, where if you have a certain MAC address in your client, the code will do goofy things in the 802.1x realm. So that's a case where single client issues are absolutely a system level problem, but it's code, and you can upgrade to fix that. But it's the first time I've seen something like that, deep down in the innards of the network that only impact, well, for me, it was 3 out of 35,000 clients, but interesting bug.
Well, that was an interesting bug indeed. Huh. Jeez. Oh, Lee, we got our first question from Scott, and he says, I'm curious, how often do you come across cabling being at fault for wireless issues?
So I guess it would be worth saying my day-to-day is I don't put in generally new wireless networks. We have a big enterprise network. That is my primary day-to-day occupation. Every now and then we will extend it, add new APs, things like that. I generally support almost 4,500 access points. Obviously, they weren't all put in at the same time, and we do grow a little bit at a time. So again, just kind of let you know where I'm coming from. Then we have a bunch of little branches and all of that. But more often than you might think, we'll be looking at the wireless environment, and something that should be connected at gig or 5 gig is running at 100 meg. And it's like, okay, why is that? And run out and scan the cable, and depending on your environment and the particular building, we have perfectly good, pristine, well-installed cables that have been touched by somebody for some reason that absolutely are problematic. Or, if it's in a metal wire mold, it got crimped in the cover when another trade who shouldn't have been in our wire mold was in the wire mold and they did some damage. Or somehow, water found its way into a jack or whatever. So for me and my big environment, it's actually one of the leading problems where something does come up. It's not an AP that failed, and it's not, code that betrayed us. I do find that, wiring is something that I don't want to say goes bad, because it doesn't by itself, but it goes bad with human help.
Yep.
And speaking of human help, oops. Sorry about that. Speaking of human help, and we will get to that. In this discussion, just some more things to keep in mind. There's just endless permutations between the wireless and the wired. A lot of times, different teams, maybe they're installing everything, but you sometimes have different teams doing configuration. Hit on vendor codes. Problems with vendor code, the notion of best practices. It's kind of silly. Some vendors work hard, put out best practices, and then the first thing you hear when you call TAC is, yeah, we don't recommend you do that. Okay, well, it's a best practice that kind of doesn't stand up to the light of day, I guess. So there's a lot of weird stuff behind the topic at hand, but the human factors that I wanted to get at, right? People touch everything. Back to that wiring question. Um, we don't have robots yet, even though we have AI, we still have so many human hands touching everything. The design of the hardware, the wiring topologies, you name it. There's human beings involved, and bottom line there, the fact that people don't always get it right. Again, this kind of goes directly back to the question about wiring. Pause there for a moment.
No, yep, you are correct. It's like, as they used to say, the part behind the keyboard, which many times cause the problems. And I guess I shouldn't be surprised, even though it's regretful. But hey, that's why there's a lot of solutions out there to help you validate your network. So always double check when you're installing a network or your wiring. So,
yeah, absolutely. And the other part of that is don't take things for granted. Maybe somebody didn't, even the wire that was tested, a year ago, something could have happened. It's, I see every piece of wire, not to just dwell on that topic, but it's a great example. If it was done right, it was installed within the wiring standards, it was tested, it was documented. That should be a component that you can count on, yet it's also out there where people are and things can happen to it. Documentation can go bad. Somebody can do something weird in a config that they didn't mean to do and didn't even realize that they do or did. So absolutely, you use the phrase double check. Yeah, double check everything. Don't take anything for granted when troubleshooting. I would absolutely throw that out there. And then to move forward, back to the actual topic that we promised. It's probably already been conversationally established here, right? The wireless experience is very much at the mercy of how good your underlying LAN is, both the topology and the configurations. Just, wireless is only part of the bigger puzzle, and easy to point to it as a failure, when things go wrong, because that's where the users are, and I have a problem, therefore I have a problem on wireless, therefore it must be wireless, even though we know that the LAN foundation underneath is very critical. It doesn't matter if you're the Wi-Fi person. Like I said, if it feels wireless, it is wireless. That's all they know. That's all most of them know, and it's understandable if you play the empathy game. They don't know what your network is like. They don't understand the building blocks, nor should they have to. They sit down, they fire up, everything should just work. And if it doesn't work, it is 100% a wireless problem that gets reported. Can't tell you how many times something goes haywire somewhere, and we will get a very consumerish report of trouble. Can somebody please come here and reboot the router that's in my office? And they approach it from the living room quality. Something acts up, I reboot my wireless router, and so it's a very very human way to approach these problems when that's all you know. So basically on with the show. All that being said, get up to the examples that we were going to talk about.
okay.
Let's reboot that router.
Yeah, I'm guessing that since, well, after 2 years of spending your time at home, a lot of people had gone through the experience of having to reboot the routers and stuff like that, being used to call your service provider to be like, oh, Wi-Fi isn't working. Oh, you reboot the router or the modem.
Yeah, it's funny. Even I'm thinking of one case where it's not even just the end users. A lot of times, depending on how your support staff is, we've got the notion of distributed desktop people, and one guy was new to a specific area, and he didn't really quite understand 802.1x and things that you have do to get configured and all of that. And he was having problems. So one of the first emails I ever got from this guy is, well, I would like to get a key to the network closet so I can reboot routers when this stuff happens. It's not just the end user, sometimes it's ill-informed staff too. But ACLs, is one of our first examples. It's like I said before, there's so much variance on networks. You really have to understand what you're dealing with. But in my world, we have edge ACLs. Our internet pipes are quite big. We don't have edge firewalls, so we have edge ACLs that are going to impact everybody, and then we have little ACLs all over the place on different layer 3 interfaces. And depending on where you have your ACLs, when something goes wrong, it's going to be felt a different way. Like I mentioned there, the third bullet down, you can have them on a VLAN, you can have them on an SSID, servers can have their own ACLs. To get into that, sometimes you're after that very elusive, good description of the trouble, so you can understand what's going on. But one of the last cases that I had, this was within the last 3 or 4 weeks, we're setting up a new vendor wireless, and kind of for the test of this. This was not a situation where there was a CapWeb tunnel. I actually had to run a few VLANs to the AP.
Okay.
And I got everything right. I was in the building. I got it all set up. I tested each VLAN that mapped directly to an SSID. All was well. And then I went home, and a couple of weeks later, it was I was really doing a test of something in a production environment. I kind of snuck it in and didn't really tell my coworkers, and they're my unwitting guinea pigs. And what could go wrong? I tested it. Well, a few weeks later, I'm getting a call that nobody can connect to our main SSID. It's like, no, and they're all on this access point, turns out.
Okay.
And I got in and looked. It's like, well, I set it up. I know I did. Well, what I didn't do is I didn't do a right mem, and we had a massive power outage, and our UPS batteries died. So when that switch came back, I had done everything right, but my VLANs were gone. The SSID was still, broadcasting, and people are still seeing it, but the SSID couldn't hit anything on the backside. And because I didn't write mem, my VLANs are gone. And it's very, if you have a lot of VLANs, if you have a lot of complexity to your layer 2 environment, VLANs can just wreak havoc, especially when you get a lot of fingers in the pie. And people with 20+ years experience don't do right mem like they should do. But again, just one direct example of
So how did you figure out it was the VLANs? Were you just play around with the configuration? You use something to find out, or you just figured out it was like?
Oh, well, I got in and I looked, and the tie-in to the ACLs is it very much felt like an ACL. I'm sorry, I've kind of lost half of the story, but yeah. So to answer your question, I got into the switch after people are saying, it feels like I'm not allowed to talk to, this is NATO 2.1 SSID. It feels like I'm not allowed to talk to our Active Directory backend. And there was some work done in that area. So it's like that's the first place I went is, okay, somebody mucked up the ACLs. Let me look at this, because this was coming in, the whole thing was kind of set up in a test. So there's actually test ACLs as well in this thing that let my little test environment get to the Active Directory backend. I got into there. It's like, no, the ACL is just fine. Everything should be working there. And then it's like, okay, let's go looking at this other thing that should be good, but that's where I got into the VLAN side of it. But we have had the first part of that story, the ACLs, and sorry to mix topics, VLANs and ACLs, but they all go together eventually. A VLAN leads to an ACL, but that is another very common one that we have seen. The network grows, the network changes. You know, a change to one ACL ends up being done wrong, or ends up, you know, something else is, a line is wiped out on another one, whatever. Easy configuration mistakes to make there.
Yeah, and it makes sense when the users were having problems trying to connect. I guess it makes sense that, suspicion, the ACLs are misconfigured or something, and that's why we can't access anymore. In this case, it ended up being something else, but I can't blame you for suspecting that was the root cause at first. Ooh, also, we have a comment here from one of our guests or viewers, John. He says, most we experience is a DHCP full, no addresses because of the long lease time, small DHCP scope, etc. So restarting is doing the job only for a short time, but configuration need to be checked, corrected. So I'm guessing going back to one of our, well, one of the comments you made earlier, people that has the tendency of just restarting stuff, like the router story, to fix issues. But in this case, it's a little different, more DHCP. And it seems like, well, if you restart the thing, well, I guess it starts giving it IP address again, but it doesn't really fix the issue in the end. So.
Yeah, and I've been through that exact situation. You know, with 30,000 clients, and you know, just on the wired side, and then easily that many, that many on the wireless side, and then easily that many on the wired side as well. There's only so many addresses to go around. So I've been through that, where you learn that the long lease times are not your friend in many environments, but the only thing you can do is, you know, find the balance between what's too short and what's too long. And yeah, I mean, been there. And for us, the fix was, you know, short lease times for wireless clients. I think we're down to, I think, a half hour or an hour. Makes for a lot of DHCP traffic, but at the same time, that ended up being what we ended up needing to do to crack that nut, for what it's worth.
Nice.
Now, just a little bit more on ACLs, right? I mean, just in case anybody's listening who doesn't really get what we're talking about, basically something you should be able to reach isn't, something you shouldn't be able to reach is, so you got maybe a security problem. That's what we're talking about with ACL. Something can't get somewhere, and whether it's a, you know, 2 or 3 user thing, or whether it's a global thing, depends on where the ACL is. You know, maybe if it's just part of a user group impacted, somebody fudged a subnet mask in an ACL. That has happened. You know, we've seen where exactly half of a class C can get somewhere from wireless, the other half could not, and that feels pretty weird. You know, again, it comes down to wireless. I can't get to the only resource that we all use when we're on the wireless network. What is your network doing to us? Well, it's not doing anything. This is a LAN ACL, basically, that needed to be fixed. You know, and then one thing that I'm seeing too, just on the topic of ACLs, the more cloud stuff you get, you know, you've got a lot of vendors out there who are trying to move their wireless management to the cloud. You know, if you don't have edge firewalls and you're using ACLs, boy, you know, the management of the, you know, the wireless infrastructure devices can be heavily dependent on those edge ACLs not being mucked with, and understanding what they need. And the challenge there too is a lot of times the infrastructure vendors are assuming you've got a firewall. You can just put in a DNS address or a DNS name that you want the APs to be able to hit, and you're dealing with ACLs that can only work on IP addresses. So there can be some conflict and tension there too, and that's not an easy one to solve.
So, before we move on, we have another question from Mike this time. How do you monitor for access that exists but that shouldn't be there?
Access that shouldn't be there. Well, that's a great question. In our environment, and again, I can only speak to the questions with where I come from, knowing that my methodology doesn't isn't going to work for everybody. But we have a dedicated security team that through the years has built up all kinds of scheduled scans. So they are probing almost everything. And if something is open that shouldn't be, it's usually found within a matter of days or, maybe a week at the longest. And, then they go, if it's a network issue, they come to my team and, say, hey, this is leaking and, this is getting out and shouldn't be or whatever. And if it's an end user or a server admin or something that is supposed to be using, IP tables or something within the host to help with the security posture. So our answer is we have automated scans. If you're not doing automated scans and you're maybe a smaller environment that doesn't have a IT team or whatever, all I can say is you're going to have to somehow do your own auditing, whatever form that takes, the recognition that, okay, this is so important that only some group of people or some group of, ports or whatever should be able to access this. And, if you're not testing, you're not going to find it. So how you craft an answer out of that simple statement is going to depend on the situation. But, you got to be looking for the problem to find the problem.
Yes, indeed. Well, thank you for the answer on that one, and thank you, Mike, for the question.
So from ACLs, already talked a little bit about VLANs with my my AP issue there, but basically, again, just a little help for what we're talking about. Basically, VLANs are a layer 2 construct. They don't have to have a gateway, but usually they do. Usually a VLAN is, some subnet and they all tie together. They get a gateway and layer 2 joins layer 3 and they become part of the network that way. You can have, and I do have totally isolated layer 2 constructs, but usually, they're part of the network and they're part of the bigger IP connected topology. It is one of the more significant network concepts, at least in traditional networking. I know, like with SD-WAN and things like that, it kind of starts to be not as important, but I don't think the VLAN is going away anytime fast for what it's worth. I had mentioned that a missing VLAN in a trunk to the AP can cause all kinds of fun. If you're in a big environment, a switch gets replaced and, I'm thinking of the NetAlly, the path analysis, and, you get all of your switches shown and switches go bad, switches get changed, configurations get changed. And, maybe between, me sitting in the library on my device, my wireless device, to get out to the internet, I have to traverse 6, 10 switches, maybe, edge switches, closet switches, distribution core switches. The wrong VLAN or the VLAN missing along that path anywhere, even if it's not the same VLAN, even if there's routing involved and I change VLANs, whatever. If my string doesn't connect from point A to point B, even though the string might change color, one VLAN to the next, I'm just not going to get there. And the whole notion of identifying VLANs that are missing, you can do it troubleshooting wise, and you can do it auditing your configuration and all of that, or you can pick up a tester. When I say troubleshooting, I mean without a tester, sitting there at the end of the problem, shooting back into the network with whatever your commands are, trying to make sense of everything going on using your brain, or you can hand off the duties to the right tester. And boy, that's nice. It's nice to be able to plug something into a port and say, what VLANs are here, and do a path analysis. Am I getting everywhere I'm supposed to go, and all of that. And so
Yes, makes it a lot easier, that's for sure. Of course, I'm sure there's people that doesn't mind spending hours doing manual commands, but hey, if you have other stuff to do, keep it simple.
yeah. Then the other part of the VLAN thing is, when you're dealing with trunking, the word add, at least in the Cisco world, you need to add a VLAN to a trunk, and you forget to say add, and you just lay in there the number of the VLAN that you want to add, but you forgot to make the word add. You've just made the trunk only be the VLAN that you're trying to add, and you wipe out all the other ones. It's so easy to do. It's valid from a command syntax, allowed procedure perspective, and it can just be devastating, and there's no warning when it happens. And if you get busy and you're doing this stuff manually, not only can you do it, but you do it, you don't even realize you did it because you're so confident in what you've done. And maybe the phone rings and you get distracted, and you do the command, you say boom, that's done, you walk away, and it's like you've just caused a world of hurt for a lot of people. And the VLAN is such an important construct that common to so many things, both wireless and wired, that it's absolutely worth kind of pondering the significance of getting it right.
Yes, indeed. Oh, and we got a comment here from Joe. He say hello or hi. Troubleshooting with VXLAN and QinQ. I think I pronounced that correctly. That is quite difficult troubleshooting. So.
Yeah, and all I can say is, yep. I am such an amateur at VXLAN. I can't even give you any tips. All I can do is nod my head and say, yep, right on, brother. Good old QoS. Endless fun. It's absolutely, its own complexity. The things that kind of confound me, or sometimes confound me, on the 802.11 side, it doesn't directly line up with the Ethernet side, right? Different tags and all of that stuff. Regardless of regardless of the products in play and the methodology, it's worth, again, pointing out, what are we trying to do? We're trying to get a handle on bandwidth, delay, jitter, loss, right? We're trying to optimize all of that for a better application experience, right? That's just the 5 cent mission statement of what QoS is. At the end of that, you're doing some kind of prioritization. Maybe you're doing, this VLAN gets the priority out of all these other ones, or you're monkeying with queues for, different applications or whatever. And, usually the old standby, easy to talk about one is voice.
Mm-hmm.
But now gaming, esports, and all of that is becoming huge. So, QoS, depending on how you look at it and the emphasis you put on gaming, but certainly financial transactions and all of that, there's getting to be ever more applications where, microseconds and milliseconds absolutely count towards something, whatever that application is doing. And you throw the concept of competition in there, again, with the gaming, or, who can do the stock transaction, faster or whatever. QoS certainly has important, targeted applications, and that's not going to go away. It's so freaking complex at times, though, to get it right end to end, and to make the wireless match up with the wired. Not only do you have to understand it all, and this is where a lot of times the I don't want to call them wizards because I hate that word, but the canned micros or whatever that the vendors might give you, just do this command and it actually lays in these other 30 commands and spares you that pain, kind of thing. That helps, but at the same time, you still have to troubleshoot it, and it still has to be end to end within your own environment. And then if it goes out onto the internet where you maybe have no more say over how the traffic is handled, or you find out that a application is being tagged incorrectly because that's the way the application was coded, it identifies itself wrong. I mean, there's so much here that can go wrong in the troubleshooting You find yourself in the world of, at least I have found myself in the world of packet capture and trying to, this is where the networking critical thought kind of comes in when it comes time to troubleshoot. I know that it's easy to say, and I'm absolutely guilty of this, the last bullet, screw QoS. We got endless bandwidth. We're never going to need QoS because we got so much freaking bandwidth. It's a nice thought, but it doesn't always work that way. And when you take that road and you say we're going to forego QoS because of the massive amount of bandwidth we got, and then something happens that QoS would have solved, then what do? You just chalk it up to we shouldn't see too much of that. We got lots of bandwidth. Or you go back and kind of rethink and implement QoS after the fact. I'm dealing with a voice environment where one of our charters, if you will, was there will be no 802.11 wireless. We'll do Ethernet connected base stations with decked wireless handsets, and that was kind of part of the project charter, if you will. And now I see that the scope is creeping into we're going to do some 802.11 phones, and I'm just kind of panicking. It's like QoS, the vendors put out these 300-page, this is how you get there from here. This is all the stuff you got to do to make your voice environment actually function over wireless the way you want it to. And it's like, yeah, we're about to roll out 802.11 onto a network that has none of that set up. And, I kind of fear, what that's going to feel like at the end. And there'll be some soul searching if it goes wrong.
Well, I don't blame you on that one. And regarding the bandwidth stuff, yeah, it's interesting because even though you have a lot of bandwidth, basically, if you're not using QoS, basically all the traffic is basically the same. So if a lot of that is being used for, I don't know, streaming or something else, but you need to prioritize voice over Wi-Fi, for example, then it's like, well, you're not giving it a high priority, so something else will go on. So, and even though that pipe is big, it's not really prioritizing the traffic that you need. Oh, we have a comment from Martin here. Keep decked for voice, he says.
Oh, that's giving a thumbs up to the decked notion.
Seems like it.
Yeah, I firmly believe in be on different spectrum. It's a proven technology, at least to me, and it works really, really well. I kind of see it backsliding, trying to do the wireless. I don't know. Got my own opinions, but at the same time, there are infinite number of absolutely functional voice over IP environments where people who truly know what they're doing with QoS have done a great job. And I will say that's one of the things I most when I run into an engineer or network architect or whatever, somebody who can just that they absolutely understand QoS so thoroughly that talking about it just comes second nature to them. Those people have my utmost respect because to me there's so many moving parts, and yes, you can follow the directions and follow the guide and hopefully get it right, but usually there's a little bit more, and usually there's a little bit of earned, learned, gained, whatever you want to call it, knowledge that is what's really going to get you over the line between success and something less than success on the QoS implementation. So boy, the people who get it, I really do respect them.
Yes, indeed. Oh, one more comment from Martin. He says, DECT is still evolving to new levels. So I guess he really is a fan. Thank you, Martin, for that.
Yeah.
He says, higher data speeds are coming, etc. Also working better with 4G and 5G.
No, that's great to know. I mean, it's It is a, like I say, proven, you know, it solved the problem for a lot of people using cordless phones. And just because it's, you know, an alternative to 802.11, it should not be shunned. You know, part of our jobs, at least the way I see it as architects and engineers, part of our jobs is sometimes pointing out that Wi-Fi is not the right technology and there are alternatives. And instead of trying to shove everything down the Wi-Fi funnel because we do Wi-Fi and we want to prove that we can do it, whatever, you know, to me, you know, sometimes there are just better ways, and DECT is one of them in the right situation. You know, so is like LoRa WAN, and, you know, sometimes Bluetooth is the right thing. And, you know, like I say, I see that as part of our jobs, is to not just be devoutly evangelize 802.11 at all costs, but to pick out the right technology for a given application.
Indeed. Yeah, Joe says, yes, absolutely. I worked for Alcatel, and DECT always worked better than Wi-Fi phones. A lot of people do not understand DSCP or QoS. And then Martin replies, follow the DECT forum for more information. Well, thank you
Beautiful.
again.
Yeah, thanks very much for that. And then the last, you know, just the last one, and I know that we're hitting these at just a super high level, but, you know, it's a webinar and there's only so much time. But hopefully we're provoking a little bit of thought, and, you know, thank you for the good discussion along the way so far out there. The notion of network tunneling, that word tunnel can be so murky. It's like, yeah, you just tunnel that. Well, what does that mean? I mean, there's so many different types of tunnels anymore. You know, you've got just the, you know, VPN, personal VPN is a tunnel. Site-to-site VPN is one of the ones, you know, I use a lot. GRE tunnels, CapWeb, depending on the vendors, and for AP management, you know, anymore. If you're from the Windows side of life, there's something called device tunnel, which is really just another personal VPN. But, you know, tunneling as a concept to me has always seemed almost like magic. You know, you've got this one VLAN with a bunch of stuff tunneled in it, or you've got this one something, and if you could cut it open, look at all the other VLANs that are inside it. It's like that freaking Harry Potter stuff right there to me. It's really empowering. You know, it lets you do a lot. One of the things that I really truly appreciated, and when lightweight access points came along, was the notion of CapWAP and the ability to have a bunch of VLANs, you know, encapsulated inside another one. And it's huge, but at the same time, it's more complexity. You know, one example of, or a couple of examples of where tunneling has bit me. You just flat out cannot get an access point to associate to its controller. It's like, okay, well, why won't it? And now you're troubleshooting the CapWeb tunnel. You got one AP out of a whole bunch of them that's just doing something goofy. Bad certificate, expired certificate, something in the AP is corrupt, you know, just something. So now you're troubleshooting that type of tunnel to figure out what's going on with this AP that nobody can connect to, and it keeps falling off the controller or going to the wrong controller. You know, that's one kind of fun tunneling. And then there's the more traditional, you know, we have police cars with, forget what the radios are. There might be some kind of ubiquity. It doesn't matter. But the police car pulls up to a parking garage that we have that's been very carefully designed for all of this with wireless, Wi-Fi wireless. They pull in, the computers in the car recognize that now they're within range of this environment, and they instantly start downloading all of their dash cam video off to the servers that are supposed to get them. Unfortunately, those servers are in the county's data center, and we are not part of the county. We are, you know, 6 site-to-site tunnels away from getting to where we need to be, and we have no visibility into their IT infrastructure, and it's just a constant, you know, we can't connect from this to that. Well, we're going to have to go look at all of the tunnels, and this is where you get into the realm of, you know, Cisco ASAs and old ancient Nortel VPN boxes and things like that. And it's just, tunneling is wonderful when it works, regardless of the application, whether it's a personal, tunnel your end device to something, or it's used in an infrastructure role. But when you start mixing vendors and you start mixing, my environment is connecting to a different environment that I have no control on or no control of, the whole notion of tunneling can get as complicated as, QoS in some ways, especially on the older devices. I know a lot of vendors have come a long way with the whole SDN thing to simplify tunneling and leverage the basic notion of tunnels to let us do ever more and make networks feel simpler, even though they're a lot more complicated programmatically in the magic tunneling boxes. But great when it works, and when it spins out, what a pain it can be to troubleshoot.
Yeah, well, like you said, tunnels are pretty popular, most for security these days and stuff. But it sounds like they're not so easy to maintain or troubleshoot, though. Okie doke. So we're running a little short on time. So I think, I don't know, Lee, if there's any other topics you have for us today.
But the only thing, I just wanted to point out, we talked about, 4 different concepts, if you will, but I'm sure everybody picked up on the nuance. They're all intertwined, right? None of these are exclusive. None of these is a standalone, one, an ACL can screw up a tunnel. A VLAN mismatch can, hose up your QoS. It doesn't matter it's a Rubik's Cube, right? It doesn't matter what thing we're talking about in relation to another thing. They can all hose each other up, and you can go down one rabbit hole and realize you need to jump over to another one because rabbit hole A was broken by rabbit hole B, and just the whole notion of interdependencies. This is complicated stuff, but it's also why people like us are on the clock to be there to fix it all.
Yep. Yes, indeed. And just in case, guys, that's why NetAlly tools are out there to help simplify all that craziness. Oh, also, Lee, we have one other question here very quickly from William. What is the estimated overhead added to bandwidth if we apply QoS, tunneling, VPN, encryption, management, etc.?
I don't know if there is a single answer. I can tell you, I can give you an example. It's only part of the answer. I do know that there is a particular IPsec-based site-to-site tunnel, very popular manufacturer, cloud managed, blah, blah, blah. And typically the encryption there will add 20 to 25% on the overhead, or 20 to 25 will be 20 to 25% overhead when the tunneling is used, and that is learned from multiple or multiple support cases where that has been said. So you've got a 500 meg internet connection, and right off the bat, if you're using site-to-site tunneling, you know that about 25% of that is going to constantly be used by that particular tunnel encryption. So that's just a subset of the question, but I think you'd have to add up all of the bits and pieces that you're talking about and see what applies where on a given application or a given topology to get your answer.
Yeah, we have also a comment from Joe. He says the average with IPsec is 20 megabytes. So I guess it adds up the more stuff you add in there.
Yeah, absolutely.
Okie doke. Lee, anything else you have for us today?
No, thanks for having me, Julio. I got to say, for all of this stuff that we're talking about, and Julio did not ask me to do this, but the NetAlly products for me have just been absolutely wonderful for almost everything I need to troubleshoot. So when you asked me to come and talk, it's something I was happy to do because, it's I'm a longtime friend of NetAlly products. They just work and they work very well. So it's nice to be able to talk with you from NetAlly because I very much use your stuff to troubleshoot a lot of this, a lot of these situations.
Well, thank you. Thank you, Lee. We appreciate it and are happy to know that the NetAlly tools have been helpful for you. Also, we then thank you for joining us today and for hosting this session of Tech Chat. It was very educational. We had a lot of good questions from the attendees or the viewers today also. So thank you everyone for participating. Also remember, if you have any other questions later, hey, feel free to contact us at NetAlly or on social media, and we'll be happy to answer those too. And well, regretfully, we ran out of time, but again, thank you everyone. I hope to see you again on the next episode of Tech Chat. And thank you, Lee. I hope you will join us again in the future.
Thank you, Julio.
Thank you, everyone.
Bye-bye.